Good morning again, everyone. My name is Anthony Wilkes with Life and Safety Consultants. Uh, Today, I will be your moderator for the webinar. Our webinar today is on energy storage systems and lithium battery safety. Uh, just as a reminder to let everyone know that you are muted, uh, that you will, that your microphones are muted. And if you have any questions, and we welcome the questions, please put your questions in the chat, and we will do our best to answer those questions. Like I said, again, I'm the moderator for the day, but today's presenter is Matt Craddock. Matt is an industrial professional with more than 30 years of experience in maintenance, electrical systems, electronics, and industrial controls across a wide range of manufacturing environments. Matt currently provides electrical engineering support, arc flash hazard analysis, electrical safety training, and workforce development service. And Matt has also served as an adjunct instructor at Greenville Technical College for the past 13 years. Matt holds a Bachelor of Science in Electronics Engineering from ECPI University and brings a extensive real world expertise in electrical safety in the industrial operations. Everyone, please welcome Matt today. Good morning, Matt.
Thank you, Anthony. Good morning.
Great, great. Well, Matt, go ahead on and get us started, and we'll follow along with you. All right.
All right. So, yes, sir. We'll go ahead and start off and launch into it. As the process is going to look a little bit like a conversation between me and Anthony, but of course, please put your questions into the chat, and we'll try to get to those as quickly as possible. I'm in presenter mode, so I'll let Anthony manage the chat. Um, So as we go through these slides and everything, if the key something kind of jogs a question or concern, or we talked about something that may we didn't go as in depth as you'd like, please let us know. As we go into the first part of it, Anthony, that we're going to start off with the ESS battery belt landscape and what this looks like in our area. So, what we're talking about here specifically is how the Southeast has changed and why we have this name or this identification of the battery belt now. And it's simply because if you look, all of the manufacturers that have moved into this area and set up shop and are working in the not just lithium battery, but all energy storage systems. And then, this could delve off into some of the other aspects that we're going to talk about, which are the data centers and support for those things. But the battery systems and these, what we call ride-through online UPS systems, all those things are part of this huge landscape now for all of us here in this area. We're looking at, somewhere around 50% of all U.S. EV battery manufacturing is concentrated in the Southeast now. It's just that people want to do work and they want to do it here. Our shipping ports are set up for this. Our infrastructure is gaining ground all the time. There's some complications with that, but we're doing the best we can. Anthony, do you want to go ahead and drive the next first question to me?
Yeah, yeah. So, Matt, for that, I understand that there's a lot of facilities here in the Southeast, and it's growing. But what is the biggest EHS challenge you're seeing organizations struggle with as they enter into this industry?
Right. That is so the industry is growing so fast that we're having trouble keeping pace with some of the demands and some of the equipment, the challenges, and not just regulatory, but just being competent with it. And I think what the one of the bigger things we have is, there's a workforce that is somewhat experienced with electrical equipment, but in energy storage systems are a whole different game. A whole different dangers and hazards are presented here. So we're all kind of learning on the fly. We're learning, and if you look it up and research it, there's programs, there's stuff built out there, but it's currently in process. And like even the NFPA versions are still in process, and they're developing as fast as the industry is. One of the other thing is, I'm going to say it. We rely heavily on a temporary type workforce. What I mean by that is we'd like to use temps and contract help. That also presents issues because, frankly, you're training and then you're training another person the next day and you're training another person the next day. So high turnover and problems with that. So there's going to be some gaps within that scope there as well. So that's some of the bigger problems we have. Um, And I think the last thing I could mention is that the emergency response planning is frequently it's everyone's got their own idea of how the emergency response plan. Everyone's got their own, things they've taken from other folks and learned, like quenches and fire blankets and evacuation methods and lithium, and just kind of like there's all kinds of problems that everyone's trying to navigate at the same time.
Thank you, Matt. Go ahead. Mm.
All right. So I guess the next one, how do lithium batteries work? So one of the things we'd like to go through real quick is talk about everyone has a little bit different terminology here, and I'll just kind of go into this one just briefly. Cell is where everyone usually starts off, and a cell is kind of universal to everyone. This is usually around 3.6 volts is the average on a cell. But the cells are constructed in series and parallel circuitry to build it into what's either could be called a module or a cassette. I see those terms kind of used interchangeably at different industry. One place will call them a module, what we call a module, they'll call a cassette, or vice versa. But nonetheless, this is where you start constructing components into battery banks. Banks are construction, and again, series and parallel wiring to get more capacity and to get more voltage. As you can see in the slide, it's up right there right now. You can see that it jumps to 600 volts DC, which arguably, I'll go ahead and tell you from a compliance factor, everything above 50 volts is considered hazardous voltage by OSHA standards. So safeguarding for equipment is just the same as production as it is for maintenance activities. It's the same thing. So whatever, when you have production equipment or you're safeguarding panels, it applies to the product you're making too on these cells. Then when you get to the pack level is where things really get dangerous. This is where we have our, what we call the high voltage chain, HV chain. This is when you're tying all of these modules and cassettes together. And sometimes it's maybe before or after what the battery management system is controlling it. And that so this could be a very much of an uncontrolled energy if the BMS is not in place. That's one of the biggest hazards we see is, as everyone has to have a plan for when a battery fails, and you have to have a different plan for each one of these stations. So at the cell station, you have to have a small plan, a module cassette plan. You have to have a different one. And then, gosh forbid, a pack fails, you have to be able to get the thing out of the plant as fast as possible, or have a method of quenching it. There's all kinds of things you have to do to make sure that you're safeguarding people, personnel, and equipment.
Okay, Matt. So is that where you get into where we talk about a thermal runaway? Why is a thermal runaway a game changer for emergency response?
Yeah, lithium batteries are not your typical electrical fire. Electrical fires can sometimes are what we call self-sustaining, which means they reignite very easily. But a lithium fire is a chemical fire. It is an electrical fire. It is there's all kinds of different. There's three hazards going on at the same time. You got heat, you got smoke and fumes, and then you got the actual flame, the fire. So, and if you're trying to fight these kind of fires, it takes special training, special gear, special apparatuses. That's not something most folks normally have. But I mean, we would have to like have specialized people in training to accommodate fighting these kind of fires. And most folks, try to put that liability on your local fire department. And the fire department will tell you also that lithium fire or something like that, they just have to let it run its course, let it run until it's done. There's no way to stop it. Now, I will tell you that in our experience, there are some really good products out there to help suppress it. And that's really where the key comes in is how can I control it to where it finally extinguishes itself? Quenching is one of those methods, dissipating the electrical energy and somewhat controlling the thermal energy. Those are probably the easiest ways that you can try and mitigate or reduce the hazard that you're being exposed to.
Man, with these thermal runaways, I've heard that they have the potential to even ignite days later or hours or days later. Is
Oh,
that true?
like the reignite?
Yeah.
Yeah, yeah. So once a cell's been damaged, that's kind of what happens. It can be dormant and slowly build heat, and then the chemical action just slowly starts more or less eating away at itself like a cancer. And as this cancer gets worse, it finally starts to build enough heat to ignite. And once the lithium's a metal, once it ignites into that catastrophic failure, it feeds itself. That thermal process is eating into the next cell, and then eats into the next cell. So this is why it's so hard to control it, and then also to keep it dormant. And this is where the quench comes in, right? So I think the quench is probably the best method of reassuring that the energy has run its full course on the battery.
Okay. Thank you, Matt.
All right. You want to move on to the next one there,
Yes,
Anthony?
go for it.
Okay. So when we're looking at the pack, there are some terms they like to use throughout the level of the pack here. And here again, cell, module, cassette, that those are interchangeable. But if you look carefully, you'll see the PPE has changed significantly as the building of the pack comes alive. And then of course the worst one would be right there at the high voltage level would be the test and commissioning packet. um, we do my customers typically do a full cycle test, which means you ramp the battery up and down and cycle it through whatever process they use, and that's usually when a failure is going to happen. And those are going to be the most severe failures. So I would say that of these all these stations, they all have their risks, but the test and commissioning one, the one about test and commissioning, sometimes packs come back, right? We get returns, or they've kicked off a line for some reason it didn't meet whatever standard, and it goes to a rework station. And I will tell you that from my experience, those reworks where they're coming in from the field as a rehab, or a device, one that's been taken off the line because something unknown, it failed some part of the quality program, that's usually when stuff, we tend to have failures. Sales are pretty much Cell levels are fairly intact, and when a cell goes bad, it's usually something very easily controlled. But these module cassettes, again, you can these are things that you can probably move by human power, right? You can actually move a module or cassette by picking it up and carrying it. It weighs less than 40 pounds in most cases. A pack, typically these packs are around 1,000 to 1,500 pounds each, and it requires special equipment to move it once it reaches this point. That's one of the bigger problems, is that you need to have heavy equipment around, and then whoever's operating that heavy equipment, they're at risk too. So yeah, it's an additional hazard that most folks don't really understand until they had one happen to them.
Right. Matt, at what level in this progression where you have to be a qualified electrical worker to work on this stuff?
That's a great question. So,
Mm,
qualified electrical worker in the state of South Carolina is defined as simply as someone who is familiar with the electrical equipment and the construction and how it
mm,
works. This electrical equipment could be, of course, like you say, maintenance activities where we're and working industrial control panels, switch gears, panel boards, even that stuff, facility stuff. But we're talking about an equipment that we're manufacturing, a battery pack, and I would say that a lot of training is required to be that familiar, to be that qualified electrical worker. There should be a fair level of on-the-job training, and a mixture of some classroom training should be, but not required. So that's kind of the thing that's I would say that gives us a lot of leeway, and we love that leeway. But at the same time, it can be working against us. So anything above 50 volts must be safeguarded and can only be worked on live by a qualified electrical worker. Normally, these are maintenance staff, the people who have had some high level of training. But no, we're talking about a production worker now. And a production worker probably doesn't have nowhere near the voltage and current and all the other experiences with Ohm's law and the intricacies of electrical energy. So you have to train them on that first, and then make them a qualified worker and explain, okay, now you got two hazards you're navigating. You got voltage and you got current. Voltage makes bad conductors better conductors. That's what you got to worry about. So when the voltage goes up, you become a better conductor. Whereas at current, it only takes as little as 50 milliamps to stop the human heart. And everything from the module, cassette, pack, and up, all the way through, all those levels have more than enough current to kill you. And then this is where EH footwear comes in, wearing shock protection on the gloves. All those things are must-haves, and just because you got an arc flash hazard, right? You got an arc flash, which means that that thing detonated in front of you and it blew up, and you were exposed to the heat, thermal energy, and the runaway. But you also got a shock hazard here, and that's what a lot of folks miss. They miss the mark on is they fail to realize that electrocution and shock by DC is extremely hazardous. So yeah, that's training people who aren't normally qualified electrical workers to be familiar with a different kind, a DC hazard, a direct current one.
Okay. Thank you, Matt.
Yeah. All right. So next slide up, Anthony, we're looking at high risk scenarios. Where are we really at risk? And I mentioned one of these already. If you look over here, damage rework sales, that one is probably the one that gets my customers, that were my current customers, that I get more calls about that than anything. And they've had incidents, they've had problems. We want to do more training. What can you do? How can we come in? Can we do the assessments? We do all that stuff. So we do try to help them. But normally I'm going to tell you that's the one. That's the one. If I were to pick one out of this six, that's the one that's going to be the most risky. High point commissioning is fairly risky involved, but normally here's the key about those. Usually you can hook those things up and then put up a barricade and walk out of the area and let it run, and no one's in the area. So gosh forbid one does fail, no one's in the immediate vicinity when it happens, and you at least have time. Plus, it's usually on a means of moving. In other words, it's near a door. Sometimes a lot of my customers are putting these stations near roll-up doors, and if they have an incident, they basically hit the roll-up door and have a procedure to push that pack right out the door and into a 20-foot cubic yard or 20 cubic yard roll-off. And then that roll-off is hauled out into the middle of the parking lot and let that puppy burn. Well, I mean, that's not the most environmental friendly thing, but it is a way of navigating the hazard. So yeah, that's really it. The high risk scenarios, everything you're doing, high voltage chain, like again, shock and electrocution hazard. Two hazards we're navigating, arc flash, and of course, electrocution.
Matt, on these high risk scenarios, can you share an example of how a routine task can quickly become a high voltage incident?
Yeah, dropped bus links, the little links that you tie and put the pieces together when you're tying. We call it the high voltage chain, HV chain. I've had two or three incidents where a customer had a fairly new person working on this, and arguably were wearing their gloves and things they were supposed to be doing, the right voltage rated gloves, but they dropped the links or hooked the link up incorrectly for the positive, negative, or the polarity, and they basically hooked one up incorrectly and caused a massive event. So those are probably your more damaging ones. So those are the ones you have to train for and keep people on their toes and let them realize this isn't as much as we like to assemble and build and do things. This is not your normal the thing that we build on assembly lines. This isn't a carburetor, So
Right.
this thing has a lot more pack. There's a lot more hazard. So yeah, in
With
the assembly process, I will say that the strapping bus bar one, that is a one that a customer of mine had in the past 6 months, and it was because a fairly new employee hooked one up incorrectly and caused a short event and had a whole battery catch on fire.
with that, Matt, on strapping and bus bars, and I see rings and watches. Are you still seeing people wear rings and watches and jewelry around this stuff?
So most of our customers have a good policy on that, but I still see it. Yes, I'm sorry to say that, but it's I see it on I just see it in lax work environment. So if you don't have that zero tolerance field to this, people tend to forget or tend to kind of push back on that. Again, you're bringing in temporary workforce. Sometimes they may not have caught on and know that's a practice. You got to be looking and paying attention. A lot of the folks have embraced non-conductive type jewelry. It's like silicone wedding bands, and that's one of the
Mhm.
things your maintenance guys know. That's a cardinal sin. Don't wear gold. Don't wear chains and stuff like that. But yeah, unfortunately, it still happens. Uh,
What Matt, on all of that time, so when an incident happens, and there was a question that came through the chat. What are some of the costs and downtime associated with the decon and the cleanup of all of this?
You know, Anthony, that's got to be another problem that everyone's having to deal with is what do you do with a battery pack once it's burned up? I mean, how do you handle this hazardous waste at this point? You got to get this is where you're going to call in. Do you use redwood materials to come pick up that wasted lithium scrap? Uh, Oftentimes, I'm not even sure they would touch it. On a standard cell that they could actually have control over to basically recycle the lithium, maybe. But one that's burned up and caught on fire, I'm not sure what you do. They can't go to the landfill. So that's kind of one of these things that the industry has not really, and again, we're talking about the battery belt, right? So what do we do
Right.
with all these things? So I'm sure there's procedure for that, but a lot of my folks just let them sit out there in a roll off, and I guess at some point
Some
we figure out how to sell it to the recycler or something. I'm hoping.
Gotcha. Got it, Matt. All right. Keep moving.
All right. So now we're going to step into your world a little bit, Anthony. We're going to talk about some regulatory and standards framework. Um, yeah. Now, I will say to most of my folks listening, I hope everyone understands there's really two different parts of the standard that apply, and that is 1910.147 lockout tagout. Now, once that has stepped in, that is control of hazardous energy. That means it is all of the voltage has been removed or the links have been removed. That's the disconnect means and stuff like that. Most likely that one's not going to be in one we can use very often, just because these cells, unless they're depleted completely, have stored energy. And when they're constructed in series and parallel circuitry above 50 volts, the lockout tagout standard applies. Where we're normally going to be dealing with is the high voltage electrical and the electrical safety PPE and dot 333 arc flash. So there's about, all these are around live electrical work. So those are typically dealing, there's special parts of the standard that deal with DC, high voltage energy storage systems. Anything above, it's usually things are above 500 volts. So those are your typical standards most people will reference. But OSHA, remember, they don't write these rules. For the most part, they just enforce these rules. They are looking at the NFPA and the National Fire Protection Agency and other regulatory, well, not regulatory, but other industries to create the standards to be adopted and used by the Code of Federal Regulations. So, EPA down at the bottom, you see that one. So there's your
Yes.
battery disposal. That what do we do with what do we do with the hazardous materials, right? So,
Right. So Matt, when you're conducting these compliance audits, what are the most common gaps that you identify, I guess?
um, so that's a great question. So the NEC, the National Electrical Code, has been doing pretty good at keeping up with the current standards and stuff. But the problem is that most of us don't go grab the NEC and just read it. Okay, you have to be someone who is actually building these things and have to, like the engineer, right? That's probably the person who's probably the most versed in it is the design engineer. But for the most part, where everyone kind of misses the gap is that the code is bad about referencing other parts of the code, and you can get lost really quick on that and realize, oh, I missed something, and then you go back and forth, and you overlook that there was some part of it you were supposed to do, and it didn't become part of your infrastructure, the thing that you built, and that's kind of probably it. So, you want to make sure you're keeping your equipment and your things. So this isn't like some off the shelf panel board. This is you're building a battery pack for a market, and you have full control over how it's constructed to fit inside the vehicle, or fit inside the telecommunication center, or to fit inside the airplane that you're constructing this storage system for. They all have them, and they all got to fit inside of a certain carriage, and that's where the design and engineer aspect comes into it. But it has to be code compliant at the same time, so that your high voltage points aren't too close where they'll arc off, or they're insulated properly, right? So
Right.
that's kind of the biggest gap we find is in design failure. A mineral insulation that they used wasn't adequate, and the battery arced over to the next cell and caused a catastrophic failure.
Wow. And it goes from can get in one cell and keep going, right?
Yep, yep, and then that's that like that cancer.
Oh yeah. Thank you, Matt. I guess we'll keep moving to the next. What's
Okay. I will mention this too, Anthony, on the International Electrical Code. This is your go-to if you're reaching, and basically if your products are coming from across the ocean. The NFPA doesn't really do that, address a lot of the things outside of the country. So a lot of times we'll have to go to the IEC to help with international standards and match them up with the NFPA, who writes the National Electrical Code, which is the NFPA 70. So the NFPA 70 is the electrical code for North America, but the IEC is the standard that we use for our customers who are making products or bringing in products from outside the US.
all right?
Okay, we're going to talk about PPE a little bit now, I guess. Anthony, you want me to just kind of talk to that real quick, or
Yeah,
do you have
yes,
any
Matt.
questions on that?
Yeah, just let's tell us about PPE. What kind of PPE needed for
Yeah.
this?
So just like electrical work inside of a control panel or a panel board or switch gear or something like that, a lot of it's the same PPE for the most part. We're navigating hazards that are direct current, DC current, and the voltage of the gloves, the rating of the glove is matched with that. So every glove for shock protection, the glove is your shock protection. The gloves don't have much for arc flash protection. I'll go ahead and tell you right now, that's where a lot of people get wrong is they choose the wrong glove. They look at the glove and they say, oh, it says arc flash glove. Yeah, that's an arc flash glove. That's not a voltage rated glove. You can't use that glove to work on electrical equipment. It is only to put inside of a boundary that has arc ratings. So it doesn't work well for that. So the shock value of the glove is how it's rated. And the class is 00 glove. It's rated for 500 volts DC, 750 volts AC. So it's important also that you make sure people are reading and understand that we're navigating DC hazards. So the column in the standard that applies to gloves, you want to make sure that it is the appropriate column. It's the DC voltage hazards and AC. Now, oftentimes, these equipment that they're using, these energy storage systems, are interfacing with systems that are inverting or creating AC waveform. If that's the case, now you have to switch over and think about AC hazards, alternating current hazards. So you got to be very well versed in these hazards as you're moving through different parts of the construction of the unit. So, typically, all of our if it's an EV product, an electrical vehicle EV product, it's going to be a VFD, an inverter in there. And that's when you have to change gears in your head physically and say, I am going to have to now navigate AC hazards instead of DC hazards. Okay. So that's one of the bigger challenges folks might run into. For the PPEs built usually again for the same but the FR rating is FR pertains strictly to arc flash. It's the gloves where you're talking about electrical protection. Also, I want to mention this too. I get a question quite often about the gloves and removing leather protectors. And the code does allow this. But it's important that you know that within that same exception to allow the leather protector to be moved for finite instrumentation, which means you're doing delicate work and you need to have dexterity and you need that leather protector removed, that's fine. But if you do, you must derate the glove by 50%, which means if it's a 500-volt glove, it is now a 250-volt glove. If it's a 1,000-volt glove, it is now a 500-volt glove. And that only carries as long as the leather protector is off. Once you put the leather protector back on, it goes back to its full voltage rating. So yeah, that's kind of the quick work through on the glove problem.
So
Gloves must be recertified every 6 months. This is not no different from the maintenance activities. Maintenance folks have to have their gloves recertified every 6 months. If you're doing production work and you're going through a lot of gloves, it would probably be more effective for you to buy a dielectric tester for testing your own gloves on site and certifying themselves. They've become more available because of this industry, the growth from it. So it makes sense to go ahead and buy some of those gloves if that's the case. Excuse me, glove testers. Inflation glove, in other words, where you inflate the glove, blow test, or stick test, we'll call it. That's required to be done daily. before each use. So those gloves, you're doing a general inspection for integrity of the glove before each use or day, or we'll say daily, because of production work. But dielectric testing, which means you high pot them, you put them through a high potential testing, usually over like, we're talking 10,000 volts. You would do that once every 6 months. Gloves that sit on the shelf, if you buy new gloves and you let them on the shelf and have them as part of your inventory, if they sit on the shelf longer than a year, guess what? Gotta have them retested. So it's, yeah, the navigating the glove problem is probably the biggest challenge my customers have.
Okay. Well, let's keep moving. Let's talk about the
Sure.
written program requirements for this.
All right. So looking at the written program requirement, ESP, that's the electrical safety program. Every factory should have one of these. This is how you work on live voltage. This is also part of it is your lockout tagout program. But the ESP is this document that says this is what our live work permit looks like. Um, so this applies to maintenance activities. Guess what? This also applies to manufacturing batteries. So when you're making ESS systems, you're doing live work, energized work permit. Now the thing is this energized work permit is if it's part of what you're manufacturing, this is your permit. This is your SOP. Quite frankly, your document on how you construct a battery pack is your energized work permit. Okay. Um, but in the maintenance activity world, this would be like we're not going to shut it down. The only exception to the work permit in the maintenance activities is testing and troubleshooting and thermal scanning, thermography, right? So that's the only
Right.
times you don't have to have a work permit. So, but we're building batteries, and it's like, well, what do we have to make a work permit to build a battery? No, your SOP, your build plan, all those things, those documents that you look at on how to construct it, that is your work permit. So that's kind of a fun one to navigate, and that's kind of a new one that a lot of folks have some good questions about. And it's just important that you, just like when you're building to an ISO standard or a TS specification, that you build that is you're doing the same steps that you would do that you would for this work permit. Um, I'll go ahead and skip to the next part
Matt,
too. Yeah,
before
go
you
ahead and
go
ask
on from
questions, sir.
that, what
Yeah.
what are some warning signs that an electrical safety or program wasn't designed with ESS operations in mind?
Um, Okay, yeah, you mean you're laying some tough ones on me now. All right.
Now, let me tell you what some of the things that I've noticed or I've had. I've found out that they don't discuss, hey, capacitor discharge verifications. Hey,
Okay.
what about all these multiple energy sources? When you are out there looking at it, when they're looking at these developing these safety electrical safety programs or even the lockout tagout program, have you noticed anything in particular
Yeah.
that is
Yeah,
not what designed for this operation? So
I have. And it's a great point. So IEC, International Electrical Code versus NEC and wire color codes. So one of the most recent problems we've had is um, industry for the international is a little different from the NEC on wire color codes and what's accepted. Typically, the battery manufacturer are using orange cables signify high voltage DC, and of course, the fact that they're orange also signifies externally fed, which means that this is you can kill the disconnect and this thing's still live. Okay. So the orange cable is kind of a standard on that, but you can also use yellow. And I saw recently a manufacturer had used black with yellow tracer. That's really not meeting the merit of it. Like it was arguably very hard for me to see the yellow tracer. It looked like a black wire. And I said, this is probably going to get someone hurt. So it's important to note that was a kind of a deficiency I found. Capacitors, of course, if you don't know, capacitors maintain their energy even after the power's off. Discharging requires a bleed down resistor or a bleed down probe, some type
mhm.
of circuitry. Typical VFDs and other types of electronic equipment that have capacitors and battery management systems have a self-discharge circuit built into them, which means that when you kill the disconnect or kill the power, usually they bleed down themselves as part of that process. Some capacitors don't have that. One's used in power factor correction and one's used in creating phase banks. Those don't have bleed down circuitry built in So they maintain their energy even after the power's off. So it's important to make sure you identify those, label them, put, I encourage good labeling and good identification, and of course, adopting good, what we call it, signal words being danger, warning, and caution. Yet you use those signal words appropriately for the hazard at play.
Mm. Matt, before we move on to the next slide, there is a
Yeah,
question that came up when we're
sure.
talking about this, and we're talking about the equipment and the safety hazards. Is UL required for all of this type of equipment?
Aha. Man, that's a loaded question.
Mhm.
UL is not required. As UL is a standard, but UL is a private organization,
Right.
and it's like anything else. Is it required that I have to submit to UL? And the short answer to that is no. But it has to meet code. Like the one thing you do have to prove is that it meets all the code, and that is the NEC National Electrical Code, NFPA 70, NFPA 799, NFPA 7. There's about 4 or 5 that we should probably look at for the energy
Right.
storage system to make sure it's compliant and built and constructed safely. So, yeah, that's a great question because you got Usted, I never can pronounce that one right. You got like 3 or 4 certifying bodies out there.
Right.
Uh, and CE would be someone that if you're talking about the European Union, but CE doesn't always match you well, and that's probably one of the people's biggest, qualms. And that's fine. You just have to prove that it meets code. That's the biggest thing I would encourage.
Okay. All right. Thanks, Matt.
Yep. All right, we don't want to move to the next few slides. I don't, so we can kind of keep things rolling, right?
Right.
All right. Yeah, looking at this one, we are ESS training tier mix. It looks like we are, awareness is everyone in the factory is awareness level. Authorized is people who are actually going to be touching live circuits or around live circuits, right? So that's kind of where I would vision most of your folks that are in the production line. Qualified electrical might be technician level. I would say these guys are usually, these persons are usually, again, have a lot of familiarity with electrical equipment, both AC, both DC. That is your QEW. He can be the guy that you would be able to take to a maintenance activity, and he knows what he's looking at, and go to a battery and an ESS storage system and also be able to identify what he's looking at. And then, of course, the last person is the EHS supervisor. This person needs to be super versatile. He or she has to navigate multiple hazards. You have to be part electrician. You got to be part environmental. You got to be, you got to be, thinking about all the other aspects of, of gas, off gassing from these batteries, and and monitoring the environment for hazardous components of the actual manufacturing process. A lot of these use epoxy and other types of volatiles that honestly can really get you in trouble from an assembly standpoint. So those are the things I would think that everyone has a role, and each person's role can't be replicated by the next person. Like there's no one person that can do all this. Everyone here should be somewhat an expert in their field. So,
Matt, real quick, have you noticed any gaps in training? I know people go through the classes and they'll sit through it, but once we talk about putting that what you've learned to practice, have you noticed any gaps?
yeah, and actually, sometimes I'm going to be honest with you, Anthony. I'm going to be a little bit convicting here that I have had to go back and change my training classes multiple times because I realized I missed the mark when I went to another factory and saw something. It's like, oh man, you know what? We didn't really cover this. So,
Mm,
it is a living document is the best way to put that. And your training program has to be a living document that is flexible to the processes as you identified unique hazards. And I like to say that my trainings are gotten to the point now where they're robust enough to where I could sell them. But
right.
I would not, like, I don't feel comfortable doing like that. That's something that's honestly I'd have to go to the factory that and do it specifically for that location. Like I can't just sell a generic. This is how you do energy storage system assembly safely, and you look at all these hazards. Everyone's a little different.
Okay. So is it, you? when you do the training, you try to be more, I guess, specific to that organization's what their needs are, right?
There's a customized level to it that yeah, I just have not been able to just use one presentation, one training analogy. You know, every one of them has been different in some regard, you know, I'm fortunate enough to where this industry, this job, this job has allowed me to walk into many different facilities and see different processes and identify new hazards based off that, and seeing how I was like, I didn't see this one, I didn't know about this, and but we always come together with a good plan. Usually EHS people and maintenance folks and engineers can all work together and come up with really good plans on how to, okay, well, we've identified a new hazard. How do we work around that? How do we, can we use a robot? Can we use some other means of doing the work without putting people at risk?
Yeah. Okay. Thanks, Matt.
So, reoccurring tasks. What are we looking at here is what is required and what is recommended. Annual, you got so you need your thermal scans. Like that's something that now that's just electrical equipment. Now, I would tell you that IR thermography is encouraged to be done on production equipment as daily. Daily, you should be scanning a battery pack or cassette or module. That should be like part of the process to have infrared thermography guns. They're not that dang expensive now. You can buy them pretty cheap. And you don't have to buy a FLIR as much as it is. Heck, you can buy a filter that goes over your camera on your phone and does a pretty good job as well too. Now they're only less than $100. Scanning should be done at minimum on every pack as it leaves from one station to the next, going from the assembly once the HV chain has been hit. Now, if you're looking at the presentation, these are more geared toward maintenance activities. So these are what's required on the NFPA 70B and NFPA 70E for maintenance activities on industrial control panels. But I will tell you that as a practice, these also apply to your energy storage systems. Whether you're sitting them in inventory, if they're sitting in on the warehouse shelves, they should be scanned periodically for thermal readings. Okay, labeling. That's kind of a fun one because again, these are around maintenance activities. You can't label a battery pack as it's rolling down the assembly line for arc flash, but are there arc flash hazards at play with a battery pack? Absolutely. So how we've been navigating that is we are labeling each station of the process as you move from one step of the process to the next one. Here is the calorie value of the pack at this station. Here's the calorific value and here's the shock value at this station. So as you move through each one of the steps, whether you call it module, cassette, or intercom line commissioning, each one of those stations has a placard, if you will, or a value associated with it that, hey, if you're going to work on a battery pack, you should be suited up to HRC category 2 at this point, and you should be wearing shock protection for 500 volts DC. So that's how you do that. Every 3 years, you need to be training on your people. If you're assembling batteries and stuff like that, you should be doing it more often. Like you should be doing it annually. You should probably have an in-house trainer, but what's required for a qualified electrical worker is every 3 years. All right. And then and that's usually there are online versions of that. I'll go ahead and tell you that too, that you don't have to have someone like me come in every time. That's cost prohibitive. Online training is available. We can actually hook you up with an LMS, and you could do it through our LMS, or you could we could actually sell you the training, and you could build your own, help you build your own, and put it on your LMS. So there's many ways to handle that. All right, every 5 years you should be reviewing all of your systems, whether it be just your infrastructure, the assembly equipment, the maintenance of aspects, all those. You should be looking at those things every 5 years. For a battery and an energy storage system, you should be looking at your process and basically how you came to those values every 5 years. And the reason I say this is because you get different customers with different needs, and your battery or your product might change. So when the product has changed, the arc flash value has changed. And that's why you have to do a reevaluation periodically to make sure that the placard or the whatever calorie value associated with it is up to date.
Okay. Well, Matt, we had a question come out of the chat is I know you talked about doing scanning regularly. Just repeat back what you're talking about doing the IR thermography scanning on a regular basis for them.
Yeah, so currently, several of my customers that are doing this are doing the thermal imaging they're doing IR scanning as a cassette or a module moves from one station to the next station just to double check it. One of my other guys that's a EV manufacturer, what they did is the batteries are coming in from an outside supplier, and they're having a fully constructed EV battery coming into the plant. They scan it before it even comes into the plant. So they scan it and once it goes into the vehicle and gets connected, it gets scanned one more time before it goes out the door. So those are constant. One of your best tools for spotting a problem is that infrared scanner.
Right.
Now, again, the NFPA 70B addresses a lot of these aspects. It's a standard that is now required. It's worthwhile for everyone to get a copy of that standard and make sure you read it thoroughly because there are different columns for different applications. And you have to look at your factory and your process to evaluate yourself to see where you stack up. Am I what we consider an extreme or a explosion hazard? There's all kinds of different parts of that you have to kind of self-evaluate and see which applies to you.
Okay. Well, Matt, as we continue on talking about continuous thermal monitoring, early fire protection, is there a
Yes.
business case to make sure you're doing continuous monitoring? So,
So yeah, there are plenty of infrared cameras out there that you can wire into your network and put up on thermal images and have displayed images pop up on TVs and in the workspace. That's probably one of the best ways. And then you can use vision systems that basically detect it and know and see a spot and actually set up a trigger and an alarm condition. There's many ways to do that, and there's some off-the-shelf ones available. So as much as our industry has grown, so have the I guess the equipment to help us do this safely, right? So if with a little bit of research, you can go out there and find plenty of imaging systems that are wired into your camera system, can be tied into your network, and basically do all the monitoring with alarming built into it.
okay. Well, Matt, you telling me, can that thermal imaging help facility move from more of a reactive maintenance culture to a more predictive one? Is that
Absolutely. Yep. So that's your one of your best tools. The predictive maintenance versus preventive maintenance versus reactive maintenance, these are key points that are keep burning. Different parts of our industry. You can get yourselves basically where you're not as profitable. So we save ourselves a lot in insurance. I'll mention this too. Insurance companies that insure these large companies, they want these things in place because they want to be able to protect what they're insuring against their assets. And if you lose half of a factory because of one thermal runaway, that's not going to be very conducive to
right?
insuring an end manufacturer. So all these things are practices that everyone wants. Predictive maintenance is the best model, of course, and it doesn't always work. And because sometimes it's not possible. I get that, we all know, but if history is a teacher, then that's something we should be doing is looking at these things at different key points. Like we've had failures at this point of this operation 2 or 3 times this year. Let's put a monitor on this thing, see if we can't detect ahead of time.
Okay. Thank you, Matt.
Yep. All right, we're rolling into thermal event responses, what to do, recognize warning signs, evacuate and isolate. Uh, the chain is going to be different for everyone. I mean, everyone, some people have their own little fire brigade. Some folks choose not to fight electrical fires, or we'll call it runaway batteries, thermal events. Some of them have to rely on, outside um, fire department or other type of assistance. That's fine. Whatever you're willing to do, right? Um, and then of course you got after it's all done, you got the post event documentation, you got the problem with the off gassing, you got the problem with dealing with the hazardous waste. Which of course, if you a little bit of research, you figure out what the process is in your area for handling hazardous waste. And usually there's folks out there who are specialized in doing that. They'll come pick it up and they'll handle it for you. Just don't make sure they don't show up in a pickup truck. Those guys, tend to get some bad press down the road. So,
Not in a pickup truck, Matt, right? Mm-mm.
hey, I'm not. I mean, I'm just saying when it's happened before, right? So, um, okay, so the biggest,
Matt, before we get too far along, one of
yeah,
the question that came in also is, I know we when we talking about these thermal events, we got all of this. Uh, is the insurance companies requiring companies to install these higher protective fire systems?
yes, most of them do.
Mm.
Most of the insurance companies, FM Global being one of the bigger ones,
Right.
is they again they have people, they have trained technicians and their own engineering staff that know what should be used for these processes. So yes, absolutely. So a lot of your, but for that very same statement, there are smaller insurance companies that don't have that, and they don't probably don't know those things, right? So they're just kind of insuring the hazard and like hoping and praying that it doesn't something catastrophic doesn't happen. It's important for your EHS people and for maintenance staff to research yourself what systems you could work for you and be put in place to help reduce the risk of what we're actually working on, right? So I would say, as much as your insurance company has a lot of push, sometimes they might miss the mark if it's a smaller company.
Okay. Thanks, Matt.
Yep. Okay. So I think we're getting toward the end of it here. I know we're getting low on time. I'll try to quit talking so much. So
You're
it's like
doing good, Matt.
there's
I
a lot
think
of
you're giving a
information
lot
in
of
here.
good info. Mm-mm.
Okay, floating HV system. I want to mention that just for a second. What that's talking about is that these systems typically aren't grounded directly to earth ground. So there, it is a high voltage system that's floating in itself. So the grounding and bonding, those terms are very crucial to what we're doing here and what we talk about. In that these are isolated systems. Heck, your car is rolling on four rubber tires for the most part. Even EV cars roll on four rubber tires. They're insulating it from earth. So these systems, the entire thing could be charged. So it's important to note that we all understand how grounding and bonding works, and then metal parts can be energized and become energized. So that everything's a risk factor there. The chassis, the frame of the battery pack are all part of that risk. Glove program. Make sure we're checking our gloves. And again, I would encourage my customers who are working in this market to look at the dielectric tester for gloves and doing it in house. There are plenty of companies doing it. I think Fastenal's doing it. There's Rebus out of Columbia. They offer this service, but it may be more cost effective to invest in your own and getting someone certified to do glove testing in house. Maybe sure we're using DC. Make sure we understand there's a direct current hazard because all gloves have two ratings on them, from one for AC and one for DC. Training, yeah, we got to go back into that one. So training should be done as often as necessary for new people and on a annual basis. At I would feel comfortable. Qualified electrical worker requirements are every 3 years, but I just don't think that's is sustained. I don't think that's correct for a production environment where you're making these systems. That's like a maintenance activity one. So I would encourage, although the standard doesn't have any difference on it right now, it still says every 3 years for qualified electrical workers. Okay. Then of course preparedness.
If you're looking at production, Matt, what was one of the suggestions you would think say for production workers?
Yeah, at minimum a year. So you do your annual trainings. Almost everyone goes to annual trainings. You don't want to become burdensome. You don't want to make it quarterly or something so bad that people just become ingrained and groggy and tune out.
Mm.
But I think yearly you should go over with your personnel. Okay, hey, by the way, and changes, updates. That's a good time to drop in. Hey, we got this new battery pack. It's got a higher capacity. There's additional hazards you should be aware of. Like those are all that's part of the timing that you should use for that. New people onboarding. I think there should be two parts to this. One is shadowing on the job, shadowing, understanding what the expectations are. Then, of course, some in the classroom stuff too.
Okay.
All right, and the last little slide there was emergency prep. Again, predictive, like you said. I think a lot of that is how do you handle a fire, having a good plan in place. Fire brigade, are we going to fight this on hand? Do we have equipment? Do we have PPE? Can we get some outside people to help train us and get us ready for that? Do we have fire blankets? Do we have fire stopper or foaming agents? Do we have a quench bath? Do we have a roll off? Do we have a plan if the battery fails here? There's a lot going into this that keeps an EHS person on their toes. Let's just be honest. So, yep. All
Right.
right. I think we're at the end here. This is one of the many ways that our company is capable of helping you with your all these different things we've talked about. We're of course well versed in both the maintenance aspects of everything and of course energy storage system manufacturing processes. We also have some experience in the raw materials side of it. So if you need some help with that side of it too, we can help that as well.
Matt,
Yeah.
Matt, for life and safety, what does a typical engagement looks like?
Um, Usually it starts off with a quick conversation between me and an EHS person or a maintenance person who has identified a hazard and they want to get our take on it. And then I come in and usually I'll look at it and not just look at it for that one incident, but I'll start doing like, hey, while we're here, let's just look at the entire thing. And that's usually where the good conversations start. So usually is once you have identified there's a need, I come in or someone on my staff will come in and we can kind of look at that one need and then slowly not we don't want to throw everything out the door, but we want to make sure that we address the hazard that you have stated, but also let's also entertain the fact there might be additional hazards and let's look at this together.
Okay. All right.
Well,
Well,
go ahead, sir.
well, Matt, I guess this brings us to if there are any more questions, please drop them in the chat as we finish up here. First of all, we definitely want to thank you for your time today. And for me, if you take one thing away, let it be this, that these hazards are manageable with the right program, training, and response planning in place. Uh, I think we got another question here, Matt. Let's see what we got here.
Lay it on me.
Uh, Sounds like companies starting to use manufacturer or including these need to first complete what's the PFMEA on their process to ID the potential.
PFMEA. All right, you got me on this one. I've got to think
Yeah,
about
I don't know.
what's that acronym? Shit.
I don't know what that acronym is, Matt.
Oh, I'm gonna have to get back on that one. You got the person who sent that
That's from
question, right?
Billy at Lockheed.
Oh, Billy. Okay, I should know. Yeah, Billy.
Mm.
I'll get back to you, Billy. You got me on that
Well,
PFMEA. I
that's
should know it.
process failure
Ah,
mode and effects analysis.
ah.
Yeah.
Okay. Yeah, man, you're
Hmm.
bringing out this Lean Six Sigma stuff on me and everything.
Hmm.
Okay. Um.
Hmm.
So okay, back to that one. Uh, I think all the probably the best way to answer that is that we have tools in place to do this, right? And but sometimes it's not necessarily a cut and dry method. Like there has to be a versatile way of approaching this problem. I would say that in most cases, we're having to rewrite the standard every time. Every time we build a new battery or build a new system or build a new prop or another factor to this, we have to rewrite how we mitigate the hazards as we go through it. So it's a living document. That's my best thing I can give you that back to that my statement earlier is that all these energy electrical safety programs are going to be living documents that change as your product and your process changes. And how you mitigate and reduce those hazards is also part of that. So that would be my risk analysis approach to that.
Okay. Well, Matt, we definitely thank you for this, and for everybody on the call here, that we will be dropping this to our YouTube page, so you will get a follow-up email from us along with the link to the YouTube page. And if you have any questions directly, you can reach out to Matt directly. We have his contact information is on up on the screen, so please take a moment to look at that, and if you have any questions, just reach out. You can reach out to Matt directly. All
All right,
right.
thank you. Thank you,
We
everyone,
thank
and thank you,
everybody
Anthony.
for joining us today. Thank you so much.